Hello and welcome back to a new session on mathematics. Today we will be starting a new topic and very interesting one, and the basic of our algebra. So let's get started and see what is it all about that I'm talking in today's session. So here, as I said, it's our first day of our new concept, that is polynomials. Polynomials comes under algebra. Okay, basically I'm trying to say it is a basic concepts of algebra. Now what exactly it is, before I move into that, let's see what are the topics that will be covered under this chapter. So here is the list. Introduction, one variable, zeros of a polynomial, remainder theorem, factor theorem, and algebraic identities will be covered under this chapter. So as I said, let's get started with introduction now. So before we go ahead with what is a polynomial, let's understand what is an algebraic expression. So what is an algebraic expression? So this is the one thing, if you are clear, if this concept is clear, then everything that you learn, not just now, even in the 10th grade, becomes crystal clear. So first, let's understand what is an algebraic. What is an expression? Let's see this. So now, this 3x, what are we doing here? You can see that 3 is a constant and x is a variable, right? And then this is a mathematical operator. It can be plus or minus. So when either you have a constant and a variable together, okay, then, or you have just a constant, then you call them as terms. It is called as term. Term, one term, two term, three terms. So how many terms are there? You can see there are 3 terms in this particular expression. Now, we have an expression wherein we have 3 terms, and each term is separated by a mathematical operator. And this terms separated by a mathematical operators is called as an algebraic expression. Now, what is a coefficient? Coefficient means, say, if I say what is coefficient of x, you will say 3. It is a term, okay? It can be a variable or anything that is basically being multiplied to x. So if I say 3xy, and if I say what is the coefficient of x, will you say only 3? No, it is 3y. What am I exactly asking you here? The factors that are being multiplied to that variable or a constant. If I say what is the coefficient of 3, you would say x. So vice versa. So remember, in this particular instance, if I say what is the coefficient of 3 in this particular instance, then I mean that what is being multiplied to 3. What is being multiplied to 3 in this instance? It is xy, right? So whatever is being multiplied, or should I say the factors of that particular term, is called as a coefficient. Okay, now let's see. Yes, when we have, that was a simple expression. Now here you can see that I have a degree or an exponent, or right? Remember, number system chapter, we have spent a good amount of time understanding exponents. Anything, it can be anything raised to the power is called as an exponent, or in this case it is called as also as a degree. So the degree decides the what kind of expression. Is it quadratic? Is it linear? Or should I say cubic? And so on, right? And we will see the the types of polynomials being split into types based on this degree, and they are also divided based on their terms. I'll get into it in a minute. Now, this is definitely an algebraic expression. Now, if this is an algebraic expression, what is a polynomial? Right? What is a polynomial? See here the degree or the exponent or the power in whichever is convenient to you, you can use those terminologies. Here the power is 2, right? Now here it is 2. Here the power is in the fractional part or p by q form, right? So what does it mean? Is this a polynomial? Is this a polynomial? I know I've written not a polynomial. If it is not a polynomial, then why is it not a polynomial? See, definitely this is an expression. No doubt about it. Okay? It is an expression, algebraic expression. But why is it not a polynomial then? Is my question. See here, whenever you have a fractional part raised, right? When I say fractional, I mean to say p by q form. Okay, whenever it is raised, the degree of the variable is not a whole number. When I say whole number, yes, when you have a 0, also I can call it. For example, 2 into x power 0, yes, it is a polynomial, right? Or 2 into x power 1, yes, it's a polynomial. So the degree should be, and now you will be wondering when I say whole, it should be a whole number. Can I have negative numbers? Say if it was -2 here, do you think it would have been still been a polynomial? No. Negative numbers are also not included. Either I say whole numbers, the power should be or the degree should be a whole number, or I should be saying non-negative integers. The degree of the polynomial either should have non-negative integers. In other way, in a more simpler words, if I have to say, I will simply say whole numbers. Yes, even if it is raised to the power of 0, it is still a polynomial. Clear? And definitely this is not a polynomial, but yes, it is still an algebraic expression. So yes, this is also a polynomial. Now, as I already said, what are not polynomials? When will an algebraic expression will not be a polynomial is whenever, see, 1 by x, here you might be wondering, the power is still positive. But see here, it is the variable is in the denominator. If I use negative exponents, this is equal to x power -1, right? Therefore, this is not equal to, x power -1. Therefore, it is not equal to, the degree of the polynomial is not positive. So, therefore, it is not a polynomial. What about this one? It is x raised to half. And definitely this is 1 by 3. Again, not a polynomial. Here I have a negative degree. Therefore, again, not a polynomial. You should be very, very, very careful when, because you need this even in the 10th grade. This is a very basic concept. Okay, let's see it forward. Now, check if the following expressions are polynomials or not. This is just a warm-up. I will do random questions here. The questions that I do not solve it right now, you will do it on your own. Okay? So let's get started. Is this a polynomial? Definitely. See, these are all expressions. No doubt about it. Check if that is why the question says, check if the following expressions, okay, they are expressions. No doubt about it. Are they polynomial? You need to check that. This one, quite simple, yes. Now, what about this? This is nothing but x raised to half plus 2. Is it a polynomial? Nah, right? This again, can also be written as this way. So again, it's not a polynomial. Definitely these are polynomials, right? I'm doing everything for you so that you don't have any confusion. What about the other one? This one, try. This is your homework. Try this, okay? Now, what about the next one? See, I'm saying the degree of the variable. I never said, now if I have to rewrite this equation, if I write this like this, minus 2 by 5 t cube plus 2 to the power of half. Same thing on this way, okay? T square minus t plus 7 by 9, right? This is the expression that we have. Is it a polynomial? See here, definitely the degree of the variables is all positive. But I have a number which has a, should I say a constant which has a fractional degree or fractional power. So is it a polynomial? Will it impact on an expression being a polynomial or not a polynomial? What do you think? Give it a thought. Definitely here, since it is a constant, it does not impact an expression from being a polynomial or not a polynomial. So therefore, this is definitely a polynomial. All right? So let's see the nomenclature, or let us see on what basis this polynomial is divided. Basically, polynomials are divided, based on terms. We have one category of polynomials. Based on the degree, we have another category of polynomials. So what are these? If I have a single term, okay, then that term is called as monomial. Mono means one. Meal, meal. Okay, so monomial. So I have only one term. How many variables are there will not impact it. If I have a mathematical operator, say in this example, if I have only one term, it is monomial. If I have a mathematical operator, so if I write plus 0, will it impact? This does not have value at all. So it doesn't matter. All right. So therefore, it is still a monomial. Whereas this one, if I write plus 1, immediately that plus 1 has some value to it. So you cannot say it is a monomial. No. Because just because you see only one variable sitting there. No. No. It is definitely plus 1. If immaterial, it's a constant also. It will become a binomial. Bi means 2. Okay, on the same lines, if you have 3 terms, it is trinomial. If you have 4 terms, quadrinomial, and hence polynomial. Clear? Next. Then degree of highest total power of variables in the of the terms is the degree. It defines the what do I say? The number of degrees defines it. Is it a polynomial or is it linear? Linear means what? When you have a single term. So here it is. So whenever you have a single term, see here, definitely one term, okay, but what is the degree of this? Degree is 0. I can write this as x to the power of 0 or y to the power of 0, right? It's still, even the constant is a polynomial, but you call it as a constant polynomial where the degree is raised to 0. Okay, then linear means now I can have one more variable here, doesn't matter, right? Number of terms will not impact if it is linear or quadratic. It's just the degree that matters. See here, the degree is 1, so it is a linear polynomial. Next, same way, if the degree is 2, it becomes quadratic. If the degree is 3, it becomes cubic. If the degree is 4, then it becomes biquadratic polynomial. Clear? Okay. Now with this basic information, let's move ahead for polynomial in one variable. What does it say? You can see that. What do I mean polynomials in one variable? I will have only one variable, either x or y. I will not have two variables there. So therefore, polynomial in one variable, let's see the generic way of it. So this is an example of polynomial in one variable, because you do not find any other alphabets sitting here, right? Not necessarily all the time it has to be x. It could be z, p, q, r. When you are solving questions, we will pick up different variables so that you get used to using different variables. Okay. So now, yes, this is a linear polynomial, constant polynomial, linear, quadratic, cubic, biquadratic. If I say in terms of terms, monomial, binomial, trinomial, quadrinomial, and next one also is quadrinomial. Yeah, so yes, Now, how do you write the generic way of this? Wherein these are constants, or I can say are basically coefficients of the variables. Are coefficients of what? Variable x, correct, in this particular thing. And remember, n is not equal to 0. Very important. What happens if it is equal to 0? Think about it. I will not give it out so easily. I want you all to think. What if it becomes equal to 0? Yes. Now this is the generic expression of a polynomial in one variable. Now let's see how do we compute the value, or how do we find the value of a polynomial. This is a example that is given to us. 2x square minus 3x plus 5. Now, what is the example? For x equal to 1, let's find the value of p of x. Okay, let's find the value of p of x. So, wherever x is there, okay, in this expression, wherever x is there, I will replace it with 1. So, what happens here? P of 1 is equal to 2 into, see here, p of x was there, I replaced it with 1. 2 into 1 square minus 3 into 1, or I will use a bracket, plus 5. So what is it equal to? 2 into 1 square is 2. 1 square is 1. 1 into 2 is 2. And 2 minus 3 plus 5. What is it? 2 minus 3 plus 5 is, 2 minus 3 is minus 1. Minus 1 plus 5 is, minus 1 plus 5 is 4. This is equal to 4. Now, next, for x is equal to 2. So, on the same lines, now let's find the value of the polynomial. Why do we need to find? You will come to know very, very soon. Okay? So, p of 2 is equal to 2, same expression. Huh? So, 2 into 2 square minus 3 into 2 plus 5 is equal to 4. 2 square is 4. 4 into 2 is 8. Minus 6 plus 5. So what is this equal to? So 8 minus 6 is plus 2. Plus 2 plus 5 is 7. Clear? Next, when it is minus 1. So you will write p of minus 1 is equal to 2 into minus 1 whole square minus 3 minus 1 plus 5. So what is this equal to? 2 minus 1 whole square is plus 1 or minus 1? Plus 1, right? Plus 1 into 2 is 2. Minus 3 into minus 1 is plus 3. Plus 3 plus 5. So when you add it up, what do you get? 10. So this way we find the value of polynomial. Why do we even need to find the value of the polynomial? There is a purpose for everything. You will know it very soon. So let's see another example. Find the value of the polynomial 5x minus 4x square plus 3 at x equal to 0, x equal to minus 1, x equal to 2. Let's do it. So for the first one, so first let us say, let p of x. You can also say, here I am denoting it as p of x. You can also say f of x. It all mean the same. What does this p of x denote? Polynomial of x. Or what is f of x? Function with x. Function of x. Right? That is all it means. So 5x minus 4x square plus 3. So now for the first question, x equal to 0. So we'll write p of 0 equal to 5 of 0 minus 4 into 0 square plus 3. So what happens? First two terms are nullified. Basically anything that is being multiplied to 0 will be 0, right? So plus 3 is equal to 3, right? Then second one, px equal to minus 1. So wherever x is there, I will replace it with minus 1. So what will it be? 5 into minus 1 minus 4 into minus 1 the whole square plus 3 equals to what? 5 into minus 1 is minus 5. Minus 1 whole square is plus 1. Plus 1 into minus 4 is minus 4 plus 3. So it is minus 9 plus 3 is minus 6. Now third question, x equal to 2. So what is P of 2? 5 into 2 minus 4 into 2 square plus 3. So what will it be? 5 2s are 10 and 2 square is 4. 4 4s are 16 plus 3. So what will it be? 10 minus 16 is minus 6. Minus 6 plus 3 is minus 3. Yes? So let's see the next. Now find P of 0, P of 1 and P of 2 for each of the following polynomials. So yes, what we can do here is take this question as your homework. Alright? And yeah. All three as your homework. Fantastic, isn't it? Let's do this. Now, see here, I have used different variables, y, t, x and x. So yes, it can be anything. When you say here, they are not saying at x equal to 0. They have just said p of 0. What does it mean? Now, in this case, y will be equal to 0. That is what you have to, it means. What is p of 0? 0 square minus 0 plus 1. So this is 1, right? On the same lines, what would be P of 1? 1 square minus 1 plus 1. What happened? This became 0. Now next, P of 2. That is 1 square minus, 2, right? Yeah, 2. 2 square minus 2 plus 2. This is 2 square is 4, minus 2 plus 2 becomes 0. So this is the answer. Now observe here, we had some value when for at 0 and we have some other value for when it is P of 2. But here P of 1 is 0. Now what does this mean? What is it trying to tell you? Does it make any sense to you? Yeah, what does it click? Does it? I mean, it's just the value of that polynomial at p equal to 1. But there should be some value, right? There should be some meaning, right? Now, what is it? This is what is called as a 0 of a polynomial, right? Just because it is 0, you call it as 0 of a polynomial? No. 0 of a polynomial, in other words, is also known as root of a polynomial. So what? Right? You must be wondering, what? So what? Let's see what exactly a 0 of a polynomial mean or a root of a polynomial mean. Right? So in this particular example, so let's find the values. Okay? Now, for P of minus 1 and P of 3 are 0. I am giving it out before itself. Right? Now, let's find it out. 1 square minus 2 minus 3. So this is 2, right? 2. So this is minus 5 plus 1 minus 4. Definitely these are equal to 0 because I have already mentioned this as 0. So here at minus 1 and 3 are zeros or the roots of the polynomial. In this particular, that was the previous question, right? So what are they saying? Now, a real number A, okay, is called a 0. Here, what is called a 0? This number, minus 1, this number 3 is called a 0 or a root of a polynomial or P of x if when I substitute that particular value in that equation, if that equation becomes 0, you call that as a root or a 0 of a polynomial. So what we will do is we'll take a simple equation, linear polynomial, okay, and let's plot it. Plot it in the sense, plot a graph, right? Let's plot. So if I take this as my inputs, so this is along x-axis, this will be along y-axis, okay? Let's do it. So this is the graph that you would get. Now, see here, for what value of x is P of x becoming 0? for value at half, right? Half is nothing but 0.5, right? See here it is. So what do you get? See, at this point, my P of x will become equal to 0. So this is P of x along y-axis. This is x points. Here I have taken random values of x and substituted in here and found the value of P of x. So for P of half, so let's do it. P of half is equal to 2 into half minus 1. 2 and 2 gone. 1 minus 1 is 0, right? So what does it mean? It means that whenever you plot a polynomial on a graph, it crosses or cuts the x-axis. Here, see, exactly, it is cutting the x-axis at whatever given point. If you say that 3 is a root of the polynomial or 3 is the 0 of the polynomial, it means that at the point 3, it is crossing the x-axis. Okay, that is what means the root or the 0. That is what it is trying to tell you. Okay, the other point positions are fine. The other values of P of x just indicates the position on the Cartesian plane. It's okay, right? When you are plotting, you will understand it. When you go to linear equation, you will plot linear. Yes, definitely you do not have anything plotting for quadratic though. Okay, so for linear polynomial, okay, what is the degree here? 1. So it will cut the x-axis exactly at 1 point. If it is quadratic, not necessary it has to cut exactly at 1 point. For another example, if I take, it might cut here. It could be parallel to the x-axis, or it could be parallel to the y-axis as well. So what does it mean? It means that a linear polynomial can have maximum of 1 root or no roots at all. And that's working on the same logic. A quadratic polynomial, quadratic. So degree is what? 2. So what does it mean? How many roots will it have? It will have 2 roots. When we come to that chapter, you will spend more time on it. I don't know if, okay. So yes, that is, if you have for a quadratic polynomial, it will definitely cut at 2 positions, right? Now it will cut exactly at 2. Will it, and the graph that you plot for a quadratic polynomial is called as parabola. Why is it called as parabola? Because it is U-shaped. Okay, therefore it is called as parabola, and it may cut at 2 points. It if I have to show you once for your, just for your information, it may cut like this. Okay, this is one way, the other way is like this, and the other way. So you, in both the examples, they were cutting at x-axis. Now here you see it is exactly cutting at 1 point, right? It not necessary it has to be at the origin, it could be here as well, right? So it is touching the x-axis at only 1 point. So it can, that means that a quadratic equation can also have 1 root, or the graph can also be like this. That means that it has no roots. If I draw it here, okay, it means it can have no roots. This is one what I mentioned. It can, here like this, if I plot 2 roots, if I draw it this way, again 2 roots, or here it means that it is touching at 1 point having 1 root. Clear? That is what is 0 of the polynomial. Now let's see an example of how to now find the value of the polynomial P of z. Okay, 3z square minus 4z plus root 17 when z is equal to 3. Very simple, right? Finding the value. So P of 3, so P of 3 is equal to 3 into 3 whole square minus 4 into 3 plus root 17. So this is equal to 9, 3 into 9 minus 12 plus root 17. 9 3s are 27 minus 12 plus root 17. Or this is 27 minus 12. What will it be? Huh? 15 plus root 17. So this is the value of the polynomial when z is equal to 3. I hope it's clear. Let's see the next. If p of x is equal to x square minus 4x plus 3, evaluate p of 2 minus p of 1 plus p of half. So let's do this. What do we do? First, let's find each terms, okay, each value of the polynomial, and then we will substitute in the given expression and solve it. Okay, let's find p of 2. So what is p of 2? 2 square minus 4 into 2 plus 3. So what is this equal to? 4 minus 8 plus 3. So what is it? P 4 minus 8 plus 3 is minus 4 plus 3, that is minus 1. So moving on to next, p of 1, that is 1 square minus 4 into 1 plus 3. So 1 square is 1 minus 4 plus 3. What is this? This is 0. 3 plus 1. 1 minus 4 is minus 3. Minus 3 plus 3 is 0. Next, p of half. Half square minus 4 into half plus 3. So this is equal to square, half square is 1 by 4. Do not cancel it off. Okay. Here it will get ones are, this is 2 times, minus 2 plus 3. Minus 2 plus 3 is plus 1. So 1 by 4 plus 1. Take LCM. This would be 4 ones are 4 plus 1, 5 by 4 is your answer. You can further simplify it by keeping it in a mixed fraction or in the form of a decimal point, but whatever it is. This is your answer for p of half. Now we have to substitute that, right? P of 2 minus p of 1 plus p of half, right? Let's substitute the answers here. So you get minus 1 minus 0 plus 5 by 4. So when I simplify this, what will I get? Definitely this has no value. So what will I have to do? Only minus 1 and plus 5 by 4. So LCM. So LCM is 4 minus 4 plus 5 by 4. So that is nothing but 1 by 4. This is the value of that given expression. Clear? Done. Very nice. So now moving on to division. We have learned division. Yes or no? Now, this is the polynomial division. For that, let's quickly understand the basic division and let's see how we can apply it in algebra. Arithmetic division we have all done, right? It's quite easy. But here we are doing polynomial division. So basically division, what do you do? If I say 23 divided by 3, so what do you do? 3 is bigger than 2, so I cannot just divide with 2, so I'll take the next number 3 as well. So 23, how many times? 7 times 21, and I get a 2 remainder. So this is called as, so if I have to write like this, 23 divided by 3 gives me 7 as my quotient with 2 as my remainder. I can further, this is quotient is 7, remainder is 2, right? Now, how do I verify this? Remember, now here in this particular example, what is dividend? Dividend is 23. And what is my divisor? 3. Into quotient is 7 plus remainder is 2. So what is 7 into 3? 21 plus 2 will give me 23, right? So here LHS is equal to RHS. We have seen this, right? So this is the basic of division. Now let's apply this concept, the arithmetic division, to the algebra division, or should I say polynomial division. So if I say divide p of x by g of x. So now what is p of x? P of x is my dividend. This is my dividend. And g of x is my divisor. Now whatever quotient that you get, I call it as q of x, and the remainder is called as r of x. Now if I have to rewrite the equation for verifying it, I can write it as p of x is equal to g of x into q of x plus the remainder, that is r of x. So let's see a few examples here. 3y square divided by y. So simple expression, right? We can simplify this very easily. I don't have to divide it at all here, right? So let's do it. So y and y cancel. So what remains? 3y. Or I can either use the word cancel, or I can say divide the numerator and denominator with y. What happens? Y divided by y is nothing but 1. So yes, that is what I am trying to say here. Now y and y goes, but I have here square 2x square minus 2x square divided by x. How do we simplify? Use the laws of exponents here. When you take this up here, it becomes what? X power minus 1, right? Now again one more law of what do I say? Either I can use the law of what? A per m by a power n is equal to a power m minus n, right? I will do that. So minus 2 into x square minus 1 is equal to minus 2x. This is what you get, right? Now let's apply, take it one step further ahead. Here I have already divided, right? But if I have to tell you how have I done this, how do we go about this? Let's see how to go about this. See here, I want to divide x square, x plus 3x square minus 1 by 1 plus x. I have to divide this. So what am I doing here? This is the expression, or should I say polynomial. I am rearranging it. Why am I rearranging it? Because highest degree, if I keep it, my first agenda is to eliminate that first term with the highest degree. Okay, let's do it. I've rearranged the same expression on the basis of the degree, highest degree. So highest degree comes first and then the following thing. So 3x square plus x minus 1. So I have here x square, I have here only x. So what do I need to multiply it with to make it x square? I need to eliminate this. Definitely I have to multiply it with x. So I write x. So I have here 1. But I need 3x square. So I need to write 3x, right? If I multiply 3x with x, I will get 3x square. Okay, so let's multiply that. So I get 3x square plus, I cannot stop it at that. I need to multiply even with 1. So 3x into 1 will give me plus 3x. Now division, second step is what? You subtract, right? So let's subtract. This is plus, minus into plus is minus, minus into plus will become minus, right? Now let's subtract. This entire terms gets eliminated because, or should I say 3x square minus 3x square is 0, right? Now x minus 3x is 2x. Is it plus 2x or minus 2x? Remember, whichever number is higher and its sign is the minus sign is associated with it, then your answer would be negative. Since 3x is bigger than x and has a minus sign with it, so therefore your answer will be minus 2x, and the remaining term, that is minus 1, is brought down as it is. Okay, now observe this equation, polynomial and this one. Here what is the difference? I have, it's been multiplied with minus 2, right? So if I want to eliminate this entire term, and if I want to eliminate this particular term, that is minus 2x, I need to multiply this x with minus 2, right? So what will I do? in quotient I will write minus 2. So minus 2 into x will give me minus 2x. Minus 2 into plus 1 will give me minus 2. So this is the thing. Now let's subtract. Subtract, right? Division next step is always after you multiply and then you will subtract. So minus into minus becomes plus. If you do not take care of this, what happens? You tend to add it. Minus 2x is minus 4x and not 0. Remember, we are subtracting. So just because I have a minus sign, don't get carried away with that. So minus into minus is plus. Minus into minus is plus. So minus 2x plus 2x is 0. Right? And then minus 1 plus 2 is plus 1. This is your answer. Now, if I write this here, 3x square plus x minus 1 is equal to what? Dividend. Sorry, divisor. This is my dividend. Divisor. What is divisor? X plus 1, right? X plus 1. What is quotient? X minus 2 and plus 1. This will give me the dividend back. If I multiply, simplify it, I will get back my dividend. Now, what do you see here? This is my g of x, right? Okay. Now, g of x is x or 1 plus x. Doesn't matter. X plus 1. Okay. Now, when x is equal to minus 1, how am I getting minus 1? What am I doing here? I am equating it to 0. X plus 1 is equal to 0. What happens to the value of x? What is the value of x? X is equal to minus 1. So, now I got the value of x as minus 1. Why do I need to do that? You will know it very soon. Now, I know x is minus 1. I will substitute this minus 1 into the expression, wherever I'll find the value of that polynomial. So, p of minus 1 is what? Minus 1 plus of 3 into minus 1 whole square minus 1. Minus 1 as it is. Okay. Plus 3 minus 1. What is that equal to? Minus 1 plus 3 is plus 2. Plus 2 minus 1 is plus 1. Voila. I don't have to divide it to find the remainder here. This is what is called as the remainder theorem. I will get to know what could be the remainder without actually dividing them. Okay, that is what is called as the remainder theorem. Now, I have one more example here. Let's see this. Now, 3x cube, 3x to the power of 4 minus 4x cube minus 3x minus 1. Let's fill in the blanks now. So, I have x power 4, 3x to the power of 4, and I have x here. So, what I need to multiply it with, if I have to eliminate it, I have to multiply it with 3x cube. So, let's do it. 3x cube into x is 3x to the power of 4. Minus 1 into 3x cube is minus 3x cube. So, this is minus into plus is minus. Minus into minus is plus. So, what happens? Definitely this gets eliminated. Minus 4x cube plus 3x cube will give me minus x cube. And the remaining term is written as it is. Minus 3x minus 1. Now, let's multiply it with x square. Now, since it has a minus sign, I will multiply it with minus x square. So, minus x square into x will give me minus x cube. Minus x square into minus 1 will give me plus x square. So, what happens here? Minus x cube, minus into minus is plus. Okay. So, this term gets eliminated. So, x square minus 3x minus 1. Okay. This one, let's ignore it for a while, and I need to further divide it. Now, x square minus 3x minus 1. Here I have x square, I have here x. So, I will have to multiply it with, and this is minus. This is because minus into plus is minus here. So, minus x square. So, I have to multiply it with minus x. Minus x into x will give me minus x square. Minus x into minus 1 will give me plus x. Okay. So I will subtract, this becomes plus, this becomes minus, this goes, and what will I get? Minus 3x minus x is minus 4x and minus 1 as it is. Further dividing, I have to divide it with minus 4. Minus 4 into x is minus 4x, minus 1 into minus 4 is minus 4. Again, this gets eliminated, minus 1, and this becomes plus 4, and minus 4 into minus 1 is plus 4, right? And this is on subtraction, this is becomes minus, this is, so the remainder is minus 5. So now the question arises, till when do you think again I can further continue dividing it? No, the question arises, till when I should keep doing this, or till when should I keep dividing it? See here, whenever the degree of your remainder is less than the degree of the divisor. See here, what is the degree of this remainder? Right? The degree of this remainder is 0, correct? And what is the degree of the divisor? Degree is 1. So whenever, till when you have to divide, you have to keep dividing it till the degree of your remainder is lesser than your divisor. Once it is lesser, you stop the division. That is your remainder. Okay? If I had a square here, I could have stopped at this point saying my remainder is minus 4x minus 1. Right? So if it is a quadratic divisor, then you stop it if your remainder is linear. Okay? You cannot further multiply it or further simplify it, I should be saying. Now I can need to verify this. This is definitely, I can do this way, right, to check. Now the other way, if the question says just find the remainder, if this question says find the quotient, yes, definitely you need to do all this. If the question says find the remainder only, then use this by x minus 1, equate it to 0, x is equal to 1, right? Now substitute this value in this expression, or should I say polynomial. So when x equal to 1, what will become of the polynomial? Wherever x is there, you're replacing it with 1. Without any division, I have found directly the answer, or should I say the remainder, which is minus 5, right? So this is what is known as my see here, remainder theorem. We are moving into the next concept, that is remainder theorem. Now I have to divide it by x minus 1. Here I am not going to subtract. So what will I do? Equate x minus 1 to 0, x is equal to 1. Simply substitute it to get, I will get the answer as 2. You want to verify it? Let's do it. X minus 1 divided by x to the power of 4 plus x cube minus 2x square plus x plus 1. Quite big expression, right? Yes. So x cube I will multiply. So it becomes x power 4. Then minus x cube. Subtract. So this becomes minus, this becomes plus. Gone, gone. Aha! It is not gone. It has been added up. 2x cube. Then remaining expression as it is, minus 2x square plus x plus 1. Now I have to multiply it with plus 2x square. So this is 2x cube minus 2x square. That's it. Then subtract. This becomes minus, this becomes plus. Definitely I have some subtracting here. So yes, 2x cube minus 2x cube is 0. Minus 2x square plus 2x square is 0. What remains? X plus 1. So I have x and x. So divided with plus 1. Plus 1 into x is x. Then plus 1. Sorry, x minus 1. So I need to subtract it. This becomes minus. This becomes plus. So plus x minus x is 0. Plus 1 becomes plus 2. Voila. It's the same answer, right? I have still got the same answer. Either you divide do it this long way, or you just whatever is your divisor, equate it to 0. That whatever value of x you get, substitute in the given polynomial to get the remainder. This is what is called as your remainder theorem. So p of x divided by x minus 1. This is my g of x. Okay. Yeah, this is just a generic way. So p of x is divided, if I say p of x is divided by x minus a, that is p of x by x minus a, or should I say p of x divided by x minus a, whichever way you want to denote it. So that is then what are you doing? You are basically substituting x minus a, substitute g of x to 0, then x becomes a. So for p of a is your remainder. Now this is your remainder theorem. So if p of x is divided by x minus a, q of x is the remainder, and definitely and remainder be r. Okay, this is your written in that thing. So yes, when x minus a is equal to 0, you will definitely p of a is your remainder. We have seen, right? We have solved many examples now. Now find the remainder when x cubed plus 3x squared plus 3x plus 1 is divided by. I will not do all the instances. What I will do here is I will pick up 2. One could be this and this, right? What am I doing? This is nothing but g of x. I have to divide this thing by this. So what happens if I take the third one here? I will substitute x. Here g of x is, let me write that way, g of x is equal to x. I said I have to equate this to 0. So g of x is 0. That is, therefore x is equal to how much? 0, right? Now let p of 0 is equal to 0 cube plus 3 into 0 square plus 3 into 0 plus 1. What is the remainder? 1. Simple, right? Without any complicated division, we have found the remainder. All thanks to our remainder theorem. Now let's take up the fourth one. When x plus pi, g of x is equal to x plus pi, I'll equate this to 0. That is, x becomes minus pi. Now substitute this in the value. P of minus pi is equal to what? Minus pi whole cube plus 3 into minus pi whole square plus 3 into pi plus 1. So this is nothing but minus pi cube plus 3 pi square plus 3 pi plus 1. You don't have to further simplify this. Okay. Now, because it's a cubic and takes lot of time. Okay. This could be your remainder, because pi is a constant. You can definitely simplify it by substituting the value as 22 by 7, find and further simplification. If I take up this one, fifth one, okay, 5 plus 2x is equated to 0, 2x is equal to minus 5, x is equal to minus 5 by 2. Then you substitute this in the given expression and simplify. Definitely this needs simplification. You can do this. Take this also as part of your homework and try and solve it. Okay, even this. So now I've given you the value of x is equal to minus 5 by 2 for the fifth question, which also you can take it up as your homework, because I've given you. Here the other places finding the value of x is simpler, right? Just transpose the other. Here we had to transpose the 5 first and then bring down the 2. So yes, you can please try this, and with this I will end my session here. Okay, let's do a quick recap of what we have done in our today's class. We will be continuing our discussion on remainder theorem. We will take up more questions in the next upcoming class, wherein we will be doing remainder theorem, factorization and identities in our next class. But in today's class, we have learned what is an algebraic expression, what is the difference between algebraic expression and a polynomial, and also polynomial in one variable, we have found the values of the polynomial, and when the value of the polynomial becomes 0, it is called as the 0 of the polynomial or root of the polynomial. And what does the root of the polynomial indicate? It means that it is crossing the x-axis at that particular point. That is what it means. For whatever value, it becomes 0. So I'll see you next time. Till then, take care. Bye-bye.